Hi everyone, my name is Himawan Murti Petrus from Kacamata University, and on behalf of my research group, Sustainable Mineral Processing, I would like to present our research work on geothermal beyond energy, circular valorization of geothermal brine, sustainable recovery of valuable minerals for clean energy, green industry, and advanced material application. As we know, geothermal is quite is the in Indonesia is the biggest on around the world, and this is also one of the alternative for renewable energy, aiming for net zero emission in 2060 in Indonesia. That is worldwide also applied. Instead of reducing the carbon dioxide for clean energy, there will be also a problem in geothermal installation, which is mineral scaling. It can reduce the electricity up to 40% because of this mineral scaling. And in the mineral scaling itself, silica is the most abundant instead of other element that might also possible occur in geothermal brine. One of the other element that is important is lithium. It is abundantly in comparison to lithium in seawater, it is quite abundant in geothermal brine. Having the fact that silica is most abundant mineral scaling in geothermal, it will closely related to food security in Indonesia, because in some part of land in Indonesia, usually they have quite minimum amount of beneficial substance that ready for plant to absorb. The beneficial substance, which is essential for plant to grow, is silica, because silica is responsible for the cell wall of plant to grow. So silica, instead of problem in geothermal, it can also support the food security itself. And that's the reason why we focus on silica for agro industry. And because of the quite interesting characteristic of silica from geothermal, which is amorphous, then we are aiming for, or we have objective to produce nanosilica for agro industry. And within 10 years of more than 10 years of research, actually we can produce nanosilica for agro industry, and it has a very positive evidence, not only increasing the productivity up to 50%, it depends on the soil as well as the plant itself, but also the growth of the plant, it can be enhanced. And in order to be able to not only focusing on nanosilica, we, with our partners worldwide, one of them is NTU, Swinburne, as well as Kyushu University, we differentiate the product of nanosilica. So not only nanosilica itself for the agro industry, we also have product on hydrogel embedded with nanosilica. Why? Because in Indonesia, most of the land, especially in eastern part of Indonesia, is quite marginal, at where their plantation usually depends on the existence of water. So having the hydrogel with nanosilica with swelling ratio higher than 500 times, we can apply this as an alternative to withstand or to catch water from the air, so the plant can be planted not only during the rainy season, especially in eastern Indonesia, but also in dry season. Not only that, we are also focusing on total extraction. So not only silica, but we are also focusing on the extraction of lithium from geothermal brine that nowadays is very essential, especially related to electric vehicles. So this is the implementation that we have in terms of agro industry of nanosilica. So not only in laboratory scale that we've done, but we also have implement the nanosilica into Partis field in the area of 4,000 meters square, with the, as I mentioned previously, with the increasing productivity up to 50%. And we also apply this nanosilica in marginal area, which is in karst area, in the area of around 2 hectares. In the karst area, what we plant is not paddies, but we plant production plant, for example, fruit there. So we have avocados, we have mango, we have papaya, and it seems that, not it seems, but the result is that the productivity as well as the growth of the plant, it's quite promising. It's quite positive, the result. So aside from that, as I mentioned previously, total extraction from this geothermal brine, it is indeed the underlined research objective of our research group. So we also have differentiation product of the silica as well as lithium extraction for the electric vehicle. So the objective for CO2 reduction, it can be also fulfilled. The objective of having sustainable renewable energy in terms of geothermal, by eliminating the mineral scaling, it can be also fulfilled. And then at the end, the third objective that is also very important, which is food security, it also can be impacted there or implemented there by having nanosilica with a higher productivity of plant as well as better growth of the plant itself. So at the end, the research result that we have, hopefully it can contribute closely to the SDGs number 12, which is responsible consumption and production, by recovering silica, lithium, boron from geothermal brine, and converting waste into valuable materials and reducing dependence on primary resource. Because at the moment, when we talk about this valuable element, usually we rely on primary source. And not only SDGs number 12, this research result from our research group also support the SDGs number 9, which is clean modular recovery system integrated into geothermal plants. And then SDGs number 13.1, which is the mineral recovery, avoided emission and reduced water use compared to conventional mining. SDGs number 8.5, training program and SMEs development, promote green employment and inclusive economic opportunities. And SDGs number 11, which is collaboration with local farmers group, enable community-based innovation and adoption. And last but not least, this research result cannot be realized without collaboration. So I would like to thank our collaborators, both university as well as the industry, as well as the other stakeholders, which is the farmers at this point forward. So at the end, I would like to say, from heat beneath our feet to a sustainable pit, harnessing the power of geothermal brine for a greener tomorrow. Thank you.